Hello, in this session we'll continue to look at past exam questions in algebra. We'll start with this example. Simplify 5p minus 1 minus 5p in brackets plus 2. Right, the first step is to remove the brackets. If I have a minus sign outside of the brackets, when I remove the bracket, I must change the sign of each term in the bracket. This is the distributive law. That means that whatever number I have, whatever multiplying number I have next to the bracket, I must multiply it by each number in the bracket. Now in this case it looks like I don't have a number outside the bracket that multiplies, but actually the minus sign means that I have a factor of minus 1. That means I must multiply the minus 1 outside by each term in the bracket. So I think of the minus as minus 1, and when I remove the bracket, I have minus 1 times 1, which is minus 1, and minus 1 times negative 5p. So minus and minus cancel, and I get a plus 5p plus 2. That's usually the first step, removing the brackets. And in the next step, we group the like terms together. In this case, like, for example, means terms that have a p. So this one has a p, this one has a p, and those two are just numbers with no symbols, no letters. Those two. Okay, I can rearrange them and write them as 5p plus 5p. Just put them next to each other. And then minus 1 plus 2. This step is not really necessary. We can also just do it mentally. Alright, just look at these two terms directly, because what we want to do is just to add them. Here we just need to add 5p to 5p, because when they are like terms, when both terms have a p, it's easier to add. For example, if I have 5p plus 5p, it's just 10p. Right? I like to think of 5p plus 5p like 5 apple plus 5 apple. It's just 10 apples. Okay, so that explains why I can just add the 5 to the 5 to get a 10, even though there is a p there. That's one way to think about it. Minus 1 plus 2 is the same as 2 minus 1, which is 1. Plus 1, that's the answer. 10p plus 1, and that's the answer to this question. Next question. Solve the inequality 3 minus 2x is more than 5. Solving inequality is rather similar to solving equations. In an equation we solve for x, we want to find out what number the x is equal to. But for an inequality, we want to find out the inequality for x itself. Meaning that in this case, we know that if we have 3 minus 2x, we know that this 3 minus 2x, which is just another number, has to be more than 5. Now when I want to solve this inequality, that means that I want to find out about x itself. I want to find out whether if x itself is more than or less than a certain number, and I want to know what that number is. And the steps is almost the same as solving equations. Now, almost, with some differences that we might see along the way. So let's start off by doing what we might do when we solve an equation. That is to try and make x the subject. Now we know that when we solve for x in an equation, if that inequality, that greater 2 sign is just an equal sign, if it is just an equal sign, we know what we would do. We will start moving things around so that in the end I have just x on one side. So we call that making x the subject, or solving for x. So let's carry that through. Now we know that in an equation I can just move the 3 over to the other side, and that's because I'm really multiplying 3 from both sides. Okay, so if I multiply 3 from both sides, the 3 there is gone and I have just 2x more than, and 5 minus 3 is 2. So I have that. Right. Next, I would want to solve for the x, I want to move the minus 2 away. In an equation, we could bring the minus 2 over to the other side as the bottom of a fraction. Alright? So what we would do, alright, is to bring the minus 2 over to the other side. Now the way to think about it, that I like to think about it, is that we are really dividing both sides by minus 2. Okay, we are really dividing both sides by minus 2, and if I do that, I'll get 2 over minus 2. Okay, so that's what we would do for an equation. Now, but for inequality, there is something that we must be careful of. That is, if we multiply or divide both sides by a negative number, we must change the direction of the inequality. Okay, so that would be correct if there is no minus sign here. Okay, if this is just a positive number. But if there's a minus sign that we bring over to the other side, we have to change that direction. That meaning it is actually more than, but I must now change it to less than. Okay, this part might look a bit strange if you see this for the first time. I'll explain a bit more after I've finished this question. It's almost done. Then in the next step, I just need to simplify 2 over minus 2, which is minus 1. 2 divided by 2 is 1, and I have a minus sign. So just to understand a bit more about why I have to change the direction of the minus sign, the easiest way to do that is to think of an example.
There you go.
Oh, thank you. Oh, 所以你要买东西啊？所以啊。Right, sorry about that. Where were we? Right, okay. We want to understand why when we have when we multiply both sides or divide by a minus sign, I need to switch the inequality. So as an example, let me just look at to make things easier, I'll just look at minus x is more than 1. For example, it's similar but without the 2. So I want to understand why, if I multiply both sides by a minus 1, I should change the direction of the inequality. And the easiest way to understand this is to put in some numbers for x. Alright, so for example, let's try the number. Think of a number where this is true. So for example, if x is equal to 2, is this true? If x is equal to 2, then I have minus 2 is more than 1. Okay, that's wrong. Now if I have x is minus 2, then when I put it in here, I have minus of minus 2 is more than 1. And minus of minus 2 is really plus 2. So 2 is more than 1, and that is correct. Alright, so what this means is that if I have a minus x is more than 1, x itself should really be a negative number. Alright, where I have minus x is more than 1, x is not a number that's more than 1. X is actually a negative number. That suggests that the minus sign actually give us an inequality where x should be smaller rather than bigger. Okay, and if I multiply both sides by a minus 1 and flip the inequality like this, we'll see that when x is equal to minus 2, the same, that this is still correct, because when x is minus 2, minus 2 is still less than minus 1. So in this example, what we see is that when we choose a number that is less than minus 1, it can satisfy this inequality. Okay, so this shows us quite clearly that if I want to move a minus sign to the other side, multiply both sides by a minus sign, the inequality has to change direction. Okay, so the simple reason is because the minus sign here actually turns a positive number into a negative number. Look at the next question now. Y is equal to a plus 2x over x. Find y when x is equal to a. To do this question, we substitute a into the x. So this is what we get. Just replace x by a and simplify. At the top of this fraction we have a plus 2a. That's 3a. A without a number in front is just 1a. So it's 1a plus 2a, which is 3a over a. And here we have 3a over a. Okay, 3a is 3 times a, over a means divide by a. So we have a divided by a here, which we can cancel. And the answer is 3. So that's how we do this. That's the first part of this question. In the next part, we want to make x the subject. Alright, that's part 1. Part 2, to make x the subject. Alright, we start with y equals to a plus 2x over x. To make x the subject, we need to rearrange the equation. Now, the one thing we can, that there are different ways to do this. I will explain 2 ways of doing it. One way is to divide each of these terms separately by x. The other way is to get rid of the bottom part, the denominator of the fraction. Okay, so these are 2 ways to simplify it and rearrange it. Right, let me try dividing the terms separately by x. So this would be, now I would continue to write out the equation in full, but in each step I will rearrange something. So that's usually the way to do it. And in this step, I divide each of this by x. I get a over x plus 2x over x. Now this step might look a little abstract if you are new to algebra. So just to get more familiar with what this means, I'll just think of an example, right, to understand what's really going on here. Now there are some ways to think about this, to understand this. So one way might be that if, for example, I have a fraction that looks like this, 1 plus 3 over 2. Just an example, right? If I have a fraction like this, 1 plus 3 over 2, I can write it as two separate fractions, alright, as 1 over 2 plus 3 over 2. Okay, so if you think of what you know about fractions, you can separate this into two parts. Alright, or you can think about it the other way, that the first line here is what you would get if you add these two fractions. If you add half and 3 over 2, you get 1 plus 3 over 2. That's how you add fractions, right? You add, if the denominators are the same, you add the numerators and you get 1 plus 3 over 2, and this is just going the other way. From 1 plus 3 over 2, you separate it out into 1 over 2 and 3 over 2. So this is very similar. You have two fractions here with the same denominator. If you add these two fractions, you would add the two numerators to get a plus 2x, and you put the whole thing over the same denominator. Okay, so it's easy to understand it one way, and you can also do it the other way. Now, in this question, you find that one of the terms become 2x over x. Okay, that's really 2 times x over x. And that means that I can divide x by x and cancel them. So the x is gone, replaced by times 1. Y is equal to a over x plus 2 is what I have now. Now, we mustn't forget that the question is to make x the subject. So my x is there. I still have some rearranging to do. To make x a subject means that I must rearrange this until I have the x on only one side with no x on the other side. Okay, that's what it really means. Okay, so let me try to move everything that has no x to one side. In this case, I have x on this side and I have a 2. I can move the 2 away if I minus 2 from both sides. So this is y minus y minus 2. 2 minus 2 is 0, and so that's a over x. So now I have the x on one side, but I have the a as well, so that's not good. Okay, I want to get rid of the a as well. I want to have only x on one side. Okay, let me continue over here. Right, now to get rid of the a, I can divide both sides by a. Divide this side by a, divide this side by a. Now we have to be careful when we do this. On the left side, when I divide y minus 2 by a, we must not just divide the 2 by a. We have to divide the whole thing by a. So whenever we want to do something to each side, say I want to do something to the left side, remember that we must do it to the whole expression on this side and not just one of them. Okay, so if I have y minus 2 as a whole divided by a, it looks like this: y over 2 whole thing divided by a. And in this case, if I have this divided by a, now it's tempting to say that a divided by a is 1, okay, and then we just cancel it and we get x. It's sometimes quite easy to just do this, but that's wrong. We have to be very careful here. What really happens here is that we should still have a fraction with 1 on top. Right? We are dividing the a by the a, so the a becomes 1. But there is still a fraction here, so it should be 1 over x. And this is what I have. Now I have just x on one side. So it might look as if I've got the answer, but not yet. When we say we want just x on one side, we mean really just x, and not even 1 over x is allowed. Okay, so just x on itself. Which means that we need to do something to the 1 over x. And what we could do in this case is that we can invert both sides. We can turn the fractions upside down. So this is x over 1. If I turn this upside down, and I must do the same to the other side. A over y minus 2. Right, so now x over 1 is just x itself. Alright, this is just x. So now I have the answer. I have made x a subject, and x is equal to a over y minus 2. Alright, and usually the usual way to write down the answer is to put the x on the left side and the rest on the right side. So x is equal to a over y minus 2. That's the answer. Now I've mentioned just now that there are two ways to do it. This is one way. The other way is by getting rid of the denominator. And I actually find that way less troublesome than this way. Alright, there's a lot of fractions and flipping and so on, and fractions are always more complicated. But if we can get rid of the denominator, we get rid of the fractions. Let's have a look at that way. Part 2 again. Starting from this equation, I want to get rid of the denominator. But the way to get rid of a denominator is to multiply both sides by that denominator. So I would multiply this side by x and multiply that side by x. Remember, whatever I do to one side, I must do the same to the other side. Then left and right are still equal. Left side, I have x times y, which is xy. The right side, I have this fraction times the x, and I have x here multiplying, and I have x here at the bottom. So those two x cancel and become 1. Well, be careful when you cancel something. When you cancel something, it does not become 0. When you're multiplying fractions, it becomes 1. So 1 times this, alright, just give this, and a plus 2x divided by 1 is still a plus 2x. And you see now that I have gotten rid of the fractions. There's no more fraction here. And it does look simpler. Alright, fractions always look more difficult, and it's always more complicated to work with. And now that we have no more fractions, let's look at this again. Look for the terms that have x, and that's xy here and 2x there. And always remember the question. We want to make x the subject, so we want to have just x on one side. And the first step, or the thing to keep trying, is to look for all the terms that has x, and to try to move all those terms to one side first. Alright, so that has x and that one is x. So let's move all those to the left side. Now that's already on the left side. To move this to the left side, I want to get rid of it from the right side, and the way to do that is to subtract 2x from both sides. Minus 2x from this side and minus 2x from that side. Okay, so on the left side I now have xy minus 2x. On the right side I have just a. So if you look at the 2x there and the minus 2x there, I have effectively moved 2x over to the left, and the sign has changed. Okay, I now have all the terms on the left side, but I really want just x on that side. So what can we do about this? Now if you have terms added or subtracted together, terms that contain x, the next step is usually to factor out the x. If you look at each term, you find that x is a factor, right? This is x times y, that is x times 2. So we can think of that as a factor, and we can bring it outside a bracket. So I think about a bracket there. Alright, think of putting the whole thing into a bracket, and think about taking the common factors outside. So in this case, the common factor is just x. I will take it outside the bracket, and then what remains are y from there and minus 2 from there. So that's the next step. We are one step closer to the answer now. Finally, what we have here is x times x times this number, okay, is equal to a. And since we really just want just the x on this side, we don't want that number. Alright, so that might look like a big bracket with more than one terms, but the easiest way to think about this whole bracket is usually to think of it as just a number. Okay, a bracket in the end can work out to just a number. So I want to get rid of that number, x times whatever that number is. And I can get rid of that if I divide both sides by that number. So I would divide by y minus 2. Right? Now remember, well, when we divide by y minus 2, this, remembering, alright, always that the bracket is a number, so this number and this number cancels. Okay, so that might seem like a very big thing to cancel, right? But as long as you remember that the whole bracket is one number, you're really just dividing that number by that number, and since they're the same number, you just get 1. So on the left side, we have just x now. And on the right side, I have a divided by y minus 2. I can write that as a over y minus 2. The same answer as before. Now if you look at what I've done here, and you think about the method I used just now, the first method of finding the answer, you can go through both of them and see which one you think is easier. For me, I think that this way is much easier. Okay, because there are no fractions. let's look at this example, this question now. Ada is 8x years old and Bill is y years old. Last year, Bill was 6 times as old as Ada. Form an equation in x and y and show that it simplifies to y equals to 6x minus 5. So this is the key to the question, this sentence here, that last year Bill was 6 times as old as Ada. So the first step is to think about how old Bill was and how old Ada was last year in terms of x and y. So let's do that. Last year, in terms of x and y, so Bill, right now, Bill is y years old. Last year, he must be y minus 1 years old. So that's how old Bill was last year. Ada is x years old this year. Last year, she must be x minus 1 years old. Because it's 1 year earlier, she is 1 year younger. Okay, that's our first step. Next step. Let's look at this key again, this key to the answer. Bill was last year 6 times as old as Ada. Last year Bill was 6 times as old as Ada. That means that this number must be 6 times of that number. So let me write that down. Y minus 1 must be 6 times that number. Okay? Now we must be very careful when we multiply things in algebra. If I just write the expression like this, it means that I multiply 6 by x. Okay, I multiply 6 by x, I can calculate an answer for that first, and then I minus the 1. But that would be wrong, because the 6 should really multiply by Ada's age last year, which is x minus 1. And that means that to calculate this correctly, I must really do x minus 1 first before I times 6. So I should put a bracket around the x minus 1 to make sure that and to tell us that we must do the x minus 1 first. Okay, so we must have a bracket there. Okay, and this is our equation. This is our next step. Let's look at the question again. We have to form this equation and simplify it to this. So that's what we want in the end. Now this is what we have now. So the idea is that we hope to work on this equation and rearrange it, and we hope that in the end we will get that equation. And it always helps to look at what we have now and what we want, and to see if there's some similarities. Now if you look at these two, there's the y there, but I have a minus 1 there that I don't want. I have a 6 there. Okay, I have this x minus 1 here, which is not here, and I have a 5 there, which I don't have. To start rearranging this, alright, we can, if we look at this equation, we see that we have just y on one side. So actually, the idea is that we must make y the subject for this equation. And the first thing we can do is to simplify that part. Right, I have 6 times this bracket. I can start by removing that bracket. Y minus 1. If I remove the bracket, I have 6x minus 1. Oh, 6x minus 6. Alright, each term in the bracket I must multiply by 6x minus 6 times 1, which is 6. So this is what I have. And if you look at the two again, they are more similar now. Alright, except that I still have a minus 1 on the left side here. And to get rid of that minus 1, I can multiply both, I can add 1 to both sides. I can add 1 to both sides. Then the 1 and the 1 cancel, and only y is left on the left side. And on the other side, I have minus 6 plus 1, which is minus 5. And you see straight away that if you do this, if you add 1 to both sides, you will get the answer. Right, there is another 2 parts to this question. So let me write down our result for the first part, which is y is equal to 6x minus 5. So we can use it later. Now part 2. This is the next part. In 19 years' time, Bill will be twice as old as Ada. form another equation in x and y and show that it simplifies to y equals to 2x plus 19. So that's the key information, and we follow the same idea as before. In 19 years time, okay, so after 19 years later, okay, we should remember that Bill is y years old right now, Ada is x years old right now. So 19 years later, Bill will be y plus 19 years old, and Ada would be x plus 19 years old. And we know from this key information that Bill will be twice as old as Ada. That means that this number is 2 times of this number. So let's write that down. Y plus 19 must be 2 times of this number. And remember, as before, that we should put a bracket around that. Alright, because we should calculate this number before we multiply by 2. And then we want to simplify this and hopefully get the expression that we want. If I multiply, I get 2 times x. I remove the bracket. I must multiply each term by 2. So 2x plus 2 times 19. Now, I do not multiply the 2 by 19 yet, because I notice that I have a 19 on the other side. Okay, and it might be easier if I just leave it as 2 times 19, because now I want to make y the subject. Alright, I just have y on one side, and I can do that if I minus 19 from both sides. And you see that if I minus 19 from both sides, I get just the y, just like that. And on the right side, if I have 2 times of 19 minus a 19, then I have 19. It's like having 2 apples minus 1 apple, or 2 a minus a. Alright, so 2 19s minus 19 is just 19. And the 2x is the same as the 2x here. So once we see this, we know that if we subtract 19 from both sides, we will get the answer. So this is the equation from part 2. Now there's one last part to this long question. hence find the present ages of Ada and Bill. But before I explain the answer, let me point out something first. Something important about how exam questions are often written in an exam paper. Now there are two important things in the way this question is written that we should know and that students often miss. One thing is the word hence. Now the word hence is very important. Okay, hence means that you must make use of the previous part of the question, the previous answers of the question, to help you to do this part. And that's important because many students would think that this is a whole new question and would not look at the earlier part for clues. So if you think that this is a whole new question and you look at it, look at just this part, you would have no idea what to do. Find the present ages of Ada and Bill, how am I going to do that? Alright, if this is a new question, there's no way you can do it because there's no other information. So hence means that you have to make use of the previous answer. Now the next thing to look at that I want you to take note of is this numbering. Now this is 3 i's. I'm sure you know by now that the 3 i's here just means 3, just means number 3 because this is a Roman numeral. Alright, so we can number questions by 1, 2, 3 or ABC or I. We see that all the time in exam papers. Now, but there is actually a kind of a way that exam questions are written in which we only use Roman numerals for a particular kind of situation, and that is if we expect sorry about that again. And that is if we expect, we only use Roman numerals in exam questions if we expect that the questions are related. So if you see a Roman numeral, this I, 3 i's, that means that it's quite likely that you need to make use of other parts of the question. So it's likely that the first part will be used in the next part, and the next part would use the answer from the last part. But if the numbering is 1, 2, 3 or ABC, it is likely that they are not related, completely different questions. Okay, so this is one thing to be careful of. So whenever you see Roman numerals and you see the word hence, or they don't have to come together, then be careful. Alright, if you're not sure of how to do this part of the question, it's quite likely that you have to look at the previous part for help. And in this case, definitely, hence find the present ages of Ada and Bill. We must make use of these two results from the last two parts of the question. And if I look at these two, I want to find the ages of Ada and Bill. Ada is X years old, Bill is Y years old. That means that I have to solve these two equations for X and Y. Right, Now if I have two equations with two unknowns, this is a set of simultaneous equations. Okay, and there are always two ways to do simultaneous equations like that, either by substitution or by elimination. Now in this case, I already have y and y on the two sides. So what I could do is I could subtract them. Let me take I minus II. First equation minus second equation. The way to subtract equation is that I should subtract the left side by the left side and the right side by the right side. Now the reason why this is a good thing here is because you see that I have y on the left side. If I subtract them, the y is gone, and I would only be left with x on the right side. So let's do that. Y minus y is 0. 6x minus 2x is 4x. Minus 5 minus 19 is minus 24. So that is simpler now because the y is gone. Okay, I only have x left. And I can solve for that. Let me move that to the other side. Add minus 24 to both sides. And I divide both sides by 4. So 24 over 4 is 6, and therefore x is 6. I now have the age of Ada. Ada is 6 years old. Now once I've found the value of x, once I have the value for one unknown, I can go back to the equation and find the other one. And I can use either one. So let me use 2. From equation 2, I know that y is equal to 2x plus 19. Now x is 6. I already know that x is 6. So 2x is 2 times 6 plus 19. 2 times 6 is 12. 12 plus 19 is 31. So Bill is 31 years old. So this completes our rather long question this time. And we'll stop here for this session. See you next time.